Good morning, students. We'll be taking up simultaneous differential equations. You know how to find the solution of linear equations, not differential equations, linear equations. Say you have x plus y equal 10 to x minus 3y equal 7. Now, how to solve this equation? One of the methods is that you eliminate x or y. You eliminate x, you will get y. When you get y, you substitute in one of the equations, you will get x also. For example, in this, we will be multiplying first equation by 2 and second by 1. I will get 2x plus 2y equal 20, which gives, and second one is 2x minus 3y equals 7. I have multiplied first equation by 7 and second equation by 1. So if I will subtract, this is minus, this is plus, this is minus. X goes, this is 5y equal 20 minus 7, it is 13. So I have got y equal 13 by 5. When I have y, I can find x from 1. From 1, your x is 10 minus y, means 10 minus 13 by 5, means 50 minus 13 by 5. So our x is 37 by 5. So I have got x as well as y. This is simple. You know how to solve the linear equations. Now, similarly, we have linear differential equations, simultaneous linear differential equations. This was simultaneous equations, and this was the method, one of the methods. We know different methods also, some different methods, but then this method will be used to solve linear simultaneous differential equations as well. Now, how to solve these equations? Let me take a first question. Say you have dx by dt minus y equal to 0 and dy by dt plus x equals 0. This is very simple. 1. This is 2. Now let me tell you, I'll be choosing this d by dt as my d. Earlier I was choosing d by dx as d. Here I will be choosing d by dt as d. Then the operator form is dx minus y equals 0. This is first. Then x plus dy equals 0. This is 2. Now, in order to eliminate x, this is up to you. This is now your choice whether you would like to eliminate x or y. Now, let me eliminate x. For that, you see we have dx over here. I don't have d over here. So, I have to multiply this by 1 and this by d. But whenever I will multiply by d, d is an operator. I will write operating by d, not by multiplying by d. So, I will write multiply first by 1 and operate 2 by d. What I will get? Dx minus y equals 0. Second one, dx plus d square y equal to 0. Let me subtract them. You can always choose multiplying or operating this by d and this by 1 so that you will not have to subtract. But then in order to get rid of x, I will subtract it. Minus, minus and minus. X goes, what remains is d square plus 1 operating on y equals 0. In fact, minus y and minus d square y. So minus taken outside, d square plus 1 operating on y equals 0. D square plus 1. So you have d square plus 1 operating this question, this type of questions. These type of questions you have already done. You know it is solutions given by complementary function. But remember once for all, this d, it is not d by dx. So solution will not be in terms of x. It is d by dt. So solution will be in terms of t. So auxiliary equation m square plus 1 equal to 0, which gives m equal to plus minus iota. So your alpha is 0, beta is 1. Complementary function y. What is y? E to the power 0 t. c1 cos t, c2 sin t. See, I have written in terms of solution in terms of t because our d, capital T, is d by dt. I have x function of t, y as well as a function of t. That is y. Y will be a function of t. This is your y. If you know y, you can always find dy by dt. This is your y. Therefore, dy by dt is c1 minus c1 sin t plus c2 cos t. This is dy by dt. Now, you see from 1, if you want to choose this one, you have to find, you see x, y is given, you want to find x. So this will be better to put dy by dt over here. So from 2, x is equal to minus dy by dt. Therefore, x is equal to c1 sin t plus minus c2 cos t. This is your x, this is your y. So you have found both x and y. This is the solution of the simultaneous equations. Likewise, you are doing in terms of equations. You are find x, then finding x, you are substituting in second equation, finding the value of y. Similarly here, you will find x and find y. Or if you find y, then you can substitute it and find x. Okay, this is the method. This is very simple one. And the methods which you have already done for this, every operating on y equals some function of x, those methods are to be followed in toto. I will not be showing each and everything. I will be just giving you a hint. For example, if in this question only, or let me take one more question. Let me say this is dx plus y equals sin t and dy plus x equal to cos t. Now this is a different question. Dx plus y equals sin t, dx plus y equal cos t. Okay. Or if you want, I can change it. Let me write dx minus y. One more question. Otherwise, you will get same complementary function. I don't want same complementary function. So you have one more question. Dx by dt minus y equals sin t, dy by dt plus x equal cos t. This is 1, this is 2. So symbolically, this is dx minus y equals sin t, x plus dy equal cos t. Now it is your choice whether you would like to find x first or y first. See, I will as usual eliminate x, or let me eliminate y, doesn't matter. Let me operate first by d and second by 1. Operate first by d and 2 by 1. It doesn't matter. You can multiply first by 1 and operate second by d in order to get rid of x. Now I am operating first by d. It is d square x minus d of y equal differentiation of sin t. What is that? Cos t. Then x plus d of y equal cos of t. So let me add up. I will get d square plus 1 operating on x equal to cos t. Okay, this we have got the same differential equation. So I have, okay, this is now a differential equation. F d operating on x equal some function of t. F of d operating on y equal to x. You know the solution is given by complementary function as well as particular integral. So I have to find both complementary function and particular integral. Difference is that f d operating on y is some function of t, not function of x, because your x is function of t and y is function of t. That is why you are differentiating with respect to t always. X dx by dt and dy by dt. So solutions will be in terms of t. I think this is clear. So what is the auxiliary equation? Auxiliary equation is again m square plus 1 equals 0, which gives m equal to plus minus iota. So complementary function, which is not y in this case, because right hand side is not equal to 0. This is not homogeneous. So this is c1 cos t plus c2 sin t. Particular integral, it is right hand side 2 cos t upon d square plus 1. Now see, this is a case of failure, because in this case you have to replace d square by minus a square. So what is the solution? 2 as it is, cos t upon d square plus a square, cos at upon d square plus at, it is minus x by 2a, but instead of x it is t, minus t by 2a, cos is sine, t by 2a sine t. Okay, you know, cos ax upon d square plus a square, it is x by 2a sine ax. Now instead of x you have t, so cos t upon d square plus 1 is t upon 2 into 1, because t is 1, a is 1, sine of t. This is the solution. So what is the general solution? General solution is y equal to cf plus pi, c1 cos t, c2 sin t, plus t by a is 1, t sin t. This is your y. When you know y, you can always find dy by dt. Oh, sorry. You were having d square plus 1 operating on x. You will not find y, you will find x. I'm sorry, this is x. Now dx by dt. In the earlier steps also you have to find find x only, huh? This is x. So only this step is there. Instead of y you will get x, because I have eliminated x. I will be getting y only. Dx by dt is c2 cos t minus c1 sin t plus sin t plus t cos t. Or you can combine cos and sin, your choice. So what's x? From 1, from 2, x is equal to minus cos t minus dy by d. Sorry, from 1. From 1, x is given, na? From 1, your y is, you have to find y. From 1, your y is dx by dt plus sin t. From 1, your y is dx by dt minus sin t. Now you know dx by dt. What is dx by dt? So y is equal to dx by dt. It is c2 cos t minus c1 sin t plus sin t plus t cos t minus sin t. Sin t goes. So the solution is c2 plus t cos t minus c1 sin t. this is y. So you have found y, you are already knowing x, so simultaneous equation is solved. Okay, this is how you have to proceed. If instead of sine t you would be having t square, then you have to use, it's a polynomial in t, so you have to use binomial expansion. If instead of cos you have e raised power at, you know what to do. Okay, so every method has been done, you know how to solve this. Right hand side will be different, right hand side may be different. For example, I have dx by dx by dt plus 2x plus 3y equal to 0. dy by dt plus 2y plus 3x equal to 0. Instead of 0, let me write e raised power t. Okay, now these are two equations, this is 1 and this is 2. So I will write it as d plus 2x, because d by dx is dx plus 2x is d plus 2, then 3y equal to e raised power t. Then 3x plus d plus 2 operating on y equal to 0. So if I have to eliminate x, then I will multiply, this is 1, again this is 2, multiply first by 3 and operate 2 by d plus 2. So what is it? 3 times d plus 2x, 3 3s are 9, y equal 3 e raised power t. Then 3 times d plus 2x, this is an operator operating on x, then d plus 2 square operating on y equal differentiation of 0 is 0. Let me subtract the 2. This goes. What remains is 9y minus d plus 2 whole square is d square plus 4 plus 4d y equal 3 e raised power t. Okay, 9y minus d plus 2 whole square is equal to 3 e raised power t. Or you have 9 minus, or you have d square plus 4d plus 4 minus 9 operating on y equal to minus 3 e raised power t. You have taken minus outside. This is plus d square plus 4d plus 4 minus 9 equal to minus times, that minus will come here. So this is finally d square plus 4d minus 5 operating on y equal to minus 3 e raised power t. You see, this is a question. fd operating on y equals some function of t. So solution is given by complementary function as well as particular integral. So auxiliary equation m square plus 4m minus 5 equals 0. So m is minus 4 plus minus 16 minus plus 5 4 20 by 2. So your m is minus 4 plus minus 6 36 6 by 2. So your m's are 1 and minus 5. Therefore complementary function is c1 e raised power t, c2 e raised power minus 5t. This is complementary function, not y. Now particular integral, right hand side is 3 e raised power minus t, minus 3 e raised power t. Particular integral is minus 3 e raised power t upon d square minus 4d plus 5 minus 5 plus 4d minus 5. This was the question. And you can see, if you replace d by 1, this is a case of failure. 1 plus 4, 5 minus 5. So this has two factors, e raised power t, d minus 1 and d plus 5. Now this is the factor which doesn't vanish. So I will use the formula for this function. And this is the function, this is the factor which vanishes. So I will use some other formula. So this is minus 3 e raised power t upon d is 2 place for 1. 5 plus 1 is 6 d minus 1. Okay. So this is 3 by 1 by 2 e raised power t upon d minus 1. This is d minus 1 raised power 1 and it's a case of failure. So I have to multiply by t, not x. You know, e to the power ax upon d minus a. It is x. But instead of x, I have to write t because I have function of t. So this is minus half t e raised power t. Fine. Therefore, my y is equal to complementary function plus particular integral. This is y. When I know y, I can always find dy by dt. Therefore, dy by dt is equal to c1 e raised power t minus 5 c2 e raised power minus t. Differentiation of this e raised power t is e raised power t. That of e raised power minus 5t is minus times minus half. Now this is the product rule. T as it is, e raised power t minus half. Derivative of t is 1 e raised power t. So you have both y as well as dy by dt. You have y as well as dy by dt. So you can find x from 2. X is equal to minus 1 by 3 dy by dt plus 2y. Substitute and simplify. Okay. Dy by dt, it is known. 2y, it is known. You just have to put it here and find x. So this simultaneous equation, differential equation, is solved by getting values of x as well as y. Let me take one more example. Let me write the question. Dx by dt plus 4x plus 3y, then dy by dt plus 2x plus 5y equal dx by dt plus 4x plus 3y and dy by dt plus 2x plus 5y. Let me write this. This is t and this is e raised power t. Okay. You have two functions, different functions. One is a polynomial, one is e to the power at. Now this one, I can write it as d plus 4x, because this is a very small board, I have to use it like this only now, plus 3y equal t. Then 2x d plus 5 operating on y equal e to the power t. Okay. Now let me again eliminate x. Multiply this by 2 and operate this by d plus 4. What I will get? It is twice d plus 4. 2, 3, 6y equal to t. Then 2 times d plus 4 x, d plus 4, d plus 6, 5 y equal, now differential of e raised power t is e raised power t, then 4 e raised power t. Okay. So finally you have, or let me subtract it, minus minus minus. Okay. So you have 6y minus d square, 4d plus 5d is 9d, 4 5s are 20, y equal 2t minus 5 e raised power t. These are 5s. 4 e raised power t plus e raised power t is 5 e raised power t. So it is this. Or you have, see, this is d square plus 9d plus 20 minus 6. What is that? Plus 14. Operating on y. Minus you have taken outside. It is 5 e raised power t minus 2t. Okay. This is a linear differential equation with constant coefficients. Fd operating on y equals some function of t. You will have to find complementary function as well as particular integral. Now let me find the complementary function. Auxiliary equation is m square plus 9m plus 14 equal to 0, which gives us m equal to minus b plus minus under root of b square. 81 minus 56 by 2a. What is that? 81 minus 56. 25. Okay. So it is minus 9 plus minus 5 by 2. So my m's are m is equal to minus 9 plus 5. It is minus 4, which is minus 2. Minus 5 minus 9 minus 14, it is minus 7. So complementary function is c1 e raised power minus 2t, c2 e raised power minus 7t. Fine. Now the particular integral. Particular integral is, what was the right hand side? 5 e raised power t minus 2t, right? Divided by d square plus 4d is 9d, sorry. 9d plus 14. Okay, yes, this is it. 7 plus 2 is 9, 7 2s are 14. This is the particular integral. So what is the particular integral? It is 5 e raised power t upon d square plus 9d plus 14, then minus 2d upon d square plus 9d plus 14. You see, e raised power 80. For e raised power 80, you have to replace d by a. A is 1 over here. This is 1 plus 9 plus 14, 10, 24. And for this, you have to take lowest degree term out. It is 14. This will be 1 plus minus some function of d. So d square plus 9d by 14. Or I have (5 by 24) e raised power t minus 2 by 14 is 1 by 7. Take it to the numerator. It is 1 plus d square plus 9d plus 14 whole raised power minus 1 operating on t. Now remember that this is t only, so you can differentiate only once. That is why you have to take maximum up to d. You don't have to take d square because it will be 0. So it is pi is 5 by 24 e raised power t minus 1 by 7. Okay, let me cut it short. This is 1 into t. You can go further. 9 by 14 differentiation of t, which is 1. Okay, this will be actually a plus b or 1 plus x raised power minus 1. It is 1 minus x plus its square. Its square will be square of everything, higher powers of d. What remains is only one term, which is 9 by 14 of d. And d operating on t, it is 9 by 14 only. So this is your particular integral. What is then y? Your y is CF plus pi. This is, you can find dy by dt, obviously. It's okay, you can find the derivative. Then from 2, you have to find x. From 2, x is equal to e raised power t minus dy by dt minus 5y divided by 2. From 2, you have found y, you have found dy by dt. From 2, x is 1/2 of this. You have to substitute, e raised power t is there, you have to substitute dy by dt, you have to substitute y, and you will get x. Okay, as simple as that. So you can do a lot many questions on this simultaneous differential equation. Method is same, so you don't have to worry at all if you have simultaneous differential equations of this form. But I have simultaneous equations of some other form. Let me give you some brief of that. We will be taking up in the next lecture, but you will at least see the books how this is being solved. Okay, there may be mistakes, you see, plus and minus. Please don't make an issue. Okay, you will do it of your own. Method is same, method is okay. There will be mistake, maybe. It does happen. Now, you have simultaneous differential equations of the form dx by p equal dy by q equal dz by r. This is one more method, one more way to write a simultaneous differential equation. These are simultaneous equations. These are simultaneous equations. Let me explain you how these are simultaneous equations. Where this P, Q and R are functions of X, Y and Z. Okay. Now how do they represent? How one represents a simultaneous differential equation? See how. If you have differential equation, two differential equations, P1 dx, Q1 dy, R1 dz equal to 0, P2 dx, Q2 dy, R2 dz equals 0. These are two differential equations, just like you are having simultaneous differential equations. Because these can be written as this, see, P1, Q1, R1, P2, Q2, R2 are functions of x, y and z. See, this can be written as P1 dx by dz, Q1 dy by dz is equal to minus R1. P2 dx by dz, Q2 dy by dz is equal to minus R2. See, such type of equations you have solved just now. This is first equation, dx by dz. Instead of z, we are having t, dx by dt, dy by dt, dx by dt, dy by dt. So, this is the same equation. This is the same equation. So, I have to show that this is the same equation. Now, how? Let me explain. So, these are two simultaneous equations. See, if you have to find dx, dy and dz, how will you find? You see, if you have to find dx, what you are doing, this is q1 r2 minus r1 q2. Similarly, you will find dy dz. This is known as p, this one. This is known as q, and this is known as r. And you will see that p, q, r will be functions of x. So instead of writing two differential equations of this type, we can convert them or write them in this form: dx by p, dy by q, dz by r. You already know how to solve equations. If you have two equations, linear equation x plus y minus 5 equals 0, 2x minus 3y minus 6 equals 0, you are finding it, x by y by z, 1 by n. Likewise, I have done it for dx, dy and dz, and this represents simultaneous equations. Now for simultaneous equations, you have seen that you are finding x and y. You are getting finding the at least two solutions. So this simultaneous equation will have at least two solutions. Will have two solutions. Now how to find these two solutions we'll be discussing in next lecture. Okay, but then I am giving this in this lecture only that you will see the books, you will see the method, how do we do it, why do we do it. Okay, what is the method? There are four methods, four different methods of solving this, and for four different situations. Okay, so I hope I will be uploading it right now. I hope you will see this yourself so that you will not find any difficulty in comprehending this method, because this method will be used in your second semester also, and all these four methods are in use there. So this is a very important method, please remember it. Okay, thank you very much.